Hello everyone. So today I'm going to work on this procedural snake character. So here is the preview. So as you can see, this snake character is implemented procedurally. That means there are no animations, but this tail or the body of the snake is coming dragging behind the character, regardless of whatever the turns we take in the world. So yeah, so I know this is not a complex or realistic character by any means, but this is just something I wanted to test and see how it turns out. So this is the end result we are going to get today. For this you don't really need any specific assets, just a box mesh, and this head is just something I created. Actually, this is the first I started learning modeling recently, and this is the first model I created. So yeah, let's see how to do this today. Alright, so this is the default third person map. This is what we are going to use to implement our character. So first I'm gonna do is, I'm not going to create a character from scratch. Instead I'm gonna create a child blueprint class from the third person template. I'll call it ch snake. Okay, and actually we don't need a skeletal mesh, so I'll just clear it out. Rather than using a first person template or something that doesn't have a mesh, I wanted to use this because we still need this camera, and the snake is also of course going to be third person. So I have already imported this dragon head model. Well, actually it's supposed to be a snake. Let me just drag and drop it under the capsule. It's a bit large. Let me make it smaller, like 0.5, and it should be facing forward, so rotate -90 degrees. Okay, so still it does not completely cover the capsule, encompassed by the capsule, but that's fine. We just need to test how the character works. So now, where did I? Okay, I'll assign 𝐶HSnake as the default pawn class. Okay, now this is what we get. We just have the head of the snake. Now the tail. So well, I think it would be easier if I just place the character like this and process, because we are going to do some stuff in the construction script, so we need to see those changes. Right, now to add the tail, I don't really want to add a series of boxes, so I'll add the instanced static mesh component. I'll call it ISM tail, or just ISM. That stands for instanced static mesh component. And here's the static mesh. I'll assign we have under this engine content. If you don't see the engine content, you can go to settings and enable show engine content. Then we have under engine content basic shapes cube. So I'll just use that. Select it and apply it here. And I want the body to be same color as the head, so this head is red, so I'll assign that material here. Still we don't see anything because we haven't added any instances of this instanced static mesh. Okay, now let's go to the construction script, and here let's add some instances using a loop, because we need to add more than one instance for one cubes for the tail. But since we are adding those instances in the construction script, this can get called multiple times as we make changes in the level. So first, before adding anything, we should clear instances in case we have already added instances. So if we don't have, fine. If we have, they will be cleared. Right, now let's add the loop. First index, of course, 0. Last index I'll promote to a variable. I'll call this body count. I don't have a better name than body count. Okay, and I'll keep it like 10. But we can change it to anything we want. Okay, now for each index we need to add an instance for this ISM. So here add instance, and how can we add this? Let's split this, transform, and here let's make a vector. So y and z can remain 0, but x we need to do some change, otherwise well, not just for x, if the location is identical for all the indexes, we would only see set of instances of this mesh that is overlapped on another. So I'll get the index and multiply with some value like how, I think 50, and also if I make it plus 50, the tail will be starting from the character and spread in the forward direction. So I need it to be on the back of the character, so I'll make it minus 50. Now see, we do have a tail, but it's like more like a continuous tail. We don't see any segments, which is fine, but I need to see the segments just to see properly how it works. So maybe this we can make it like 0.4, 0.6, 0.6. Now we can see a clear tail with clear segments. Okay, and here if I increase the body count, let's say instead of 10 I'll make it 50. See, it's much longer now. Okay, but now if I play, so this is what happens. It's just a tail is not actually doing anything, so that's actually not what we need. So instead of just keep the tail like attached to the character, we need the tail to follow the path of the head to achieve that, here let's detach this instanced static mesh component from the actor. Should I use detach from component? Okay, keep word, everything keep word. Right, now one more thing, let me fix the camera as well. The camera is here. I'll make the camera 1000 and maybe not 1000, a bit shorter, 800, and an offset, something like this. Now maybe a bit more. Now when we play, we can clearly see the character. And now the problem is, the head is moving, but the tail stays. Tail does not follow. So we need to make these boxes follow the head, and it has to be done through the code, otherwise it would not be procedural. Okay, so I'll write a custom event locations. So here what I'm gonna do is, I'm gonna make each box a lerp, that means linearly interpolate towards the next box. So if we continuously do that, as the head moves forward, the boxes will follow in the same path as the head. So to do that, we can get the ISM, and first, as we are going to manipulate the locations, I think it would be better to save the location of each box or each instance of this ISM into an array and use it to manipulate the locations of the boxes, the next boxes. So we can get instance count and run a loop. First index 0, last index instant count. No, not instance count, instance count -1, because the indexes is starting from 0. And here again, from the ISM, get instance transform, and with this index I'll use the world space tick. Since this is detached from the parent, I don't think that would make a difference, but anyway, I'll keep the world space. And we need to save this transform into an array. So I'll add a variable instance transforms. This should be the type of transform. Okay, get and add. Not this one. By the way, this may not be the most optimized way to do this, but I just want to test a concept. So wait, What happened here? This has to be an array. So I'm not worried much about optimization at this in time. Okay, and in the next time when we want to lerp locations, we obviously don't need previous location values, so get and clear. Alright, so once we have all the locations, we need to make the boxes follow the next box. So what should the first box follow? For that, I'll make it follow this ISM, but ISM location is also not changing, so I think it's yeah, so I'll set the first location. I'll update the location of the first instance with the character location. So update instance transform, and yeah, first instance. New instance transform should be get actor transform, and here we don't want to change the scale, so what's the scale? Right, we can get the 0th element instance transform and access the scale like this, and here also I'll mark it as world space. I think we have to enable this mark render state dirty because these are instances of static meshes. Without that, it may not update right away, but let's see. If it's not changing, let's mark it. So okay, so first location of the first instance is now updated, but we need to see that, and we are not calling these lerp locations anywhere, so let's do that. Let's call it here, but we don't need to update the locations always unless the character is moving. So I'll get velocity of the character. So here we get a vector, so I'll get length of the vector, so we can get the speed and check if this speed is greater than, maybe not 0, let's say 10. If yes, let's call lerp location. So here what I'm expecting to see is only the first box location is changing. And is it changing? I don't think so, because the first box is here. Or is it inside? It is inside. Okay, for now let me just make the head invisible. Where is the visibility? Here. Okay, still no. Even the first box is not changing location. All right, then okay, let's try marking the render state dirty and see if it is changing. Yeah, now it's changing. Alright, now what about the rest of the boxes? Right, now for other boxes, let's run a for each loop on this array. And so we need to access it. We need to get the second box and interpolate the location and the rotation to the first box, and third box to the second box, fourth box to the third box. That's what we are trying to do. So first we need to get the location of the current box. So get the ISM and get instance transform, not the current box, the box, the instance that we need to change. So that means add 1 to this. Okay, I'll enable world space and then lerp this, linearly interpolate this with the location of the previous previous, not location, with the previous transform itself. So previous transform is the value we already get here, and alpha, let's use something like this. We can change this if it's too fast or too slow, and we need to update instance transform, and this is the instance and this is the value. And I'll enable word space. Do I need to mark this also? Not sure. Let's see first. And is there a chance to try access to any other non-existing values? Maybe, but let's see if we get any errors. If not, all good. Oh, everything is working. Nice. And when we stop moving, the tail stops moving. Okay. All right. Now let's make the head visible. And here is our dragon. So the dragon can't, not dragon, a snake. If it is a dragon, it should be able to fly. And I haven't implemented flying here, so it's just a snake for the moment. Okay, so I'm gonna stop this episode right here, and I don't really have planned any more stuff. This is just some experiment I wanted to do. But if you have any ideas, like things that you would love to experiment and see, let me know in the comments. So let's see what else we can do here. Okay, so thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.